Thanks everybody. And there's a lot of great things happening. We understand that people tend to be a little bit down these days, but it's so nice for us to be out here and showing people, like actually showing people what we can now do. So again, a big shout out to the tech team as well. Yeah, just this is really our time to shine. And really looking forward to Charlie, what you're going to be showing us. So again, also huge thanks, of course, to Maya, co-host and mother of DeepSquare. Okie dokie, take it away, Charlie.
All right, welcome everybody. And first of all, let's maybe remind us what is rendering. So for those who don't know, rendering is the process of that is used to generate 2D or 3D images from models that can be done by application programs like Blender, for example. It is mostly used in video games, architectural designs, animated movies, simulators, etc. So what's the difference between render streaming and local rendering that we are used to have at home? So when you have a game, you need to first install it, and after downloading the game, you load the map when you want to play with players, and after that, you are able to synchronize the data with the other players to know their position, for example. But all the rendering occurs on the client side. This is why you need to have a good computer to play games. That is an issue, for example, with the sandbox, for example, games like that. You cannot really play these games with laptops without GPUs, for example. On the other side, you have the render streaming technology, where the rendering and the encoding is occurring on server side, meaning provided that the user has a web browser that is able to decode the stream, the user doesn't need to have strong hardware to play, which is making gaming more accessible. There are two main actors that we know about this technology. The first one is made by Unity with their product called Unity Render Streaming. And on the other side, their competitor is Unreal Engine with their pixel streaming product. In DeepSquare, we personally know a game developer that is a Unity game developer. So this is why we started to dig into this technology from the Unity side. And it is very experimental. This developer is actually contributing to the repository, and it is not yet ready, I'd say, to make AAA games. It is open source, which is very interesting, so the community can be involved and improve the product. On the Unreal Engine side, unfortunately, we don't know people that are Unreal Engine developers that are using pixel streaming. So if among us there are Unreal Engine developers, or people that are, feel free to share in the Telegram group the information, because we would love to integrate these applications in our infrastructure to test. So what's the difference between the two? So we already talked about the what is occurring on server side and client side. So this slide is not really bringing much. What are the pros and cons? So when you use traditional applications or the games on browser, of course, what is good is that you don't have rendering cost, because the end user is rendering the things on their computer. But what is bad is that you need to develop your game so that it works on most of the architectures. This is why you need to be careful that your game is still playable with low-end devices. And also you need to build your games for many targets. Also, when you are doing games that will run on browser, you have a limited build size, so that you cannot have AAA games played on the web browser, or it will be limited. On the render streaming side, however, you don't have any problem with that. You can make one build for everyone because it is actually streamed to the end users. It's like playing on Netflix, and you don't need to care about the end target device. As long as they have a red browser, they will be able to play. Also, it's very secured because people cannot scrap the information from the games to build hacks or to scrap for example, if you are making 3D models, they could steal it. Whereas when it is streamed, it's impossible. The cons of the render streaming is, of course, the rendering cost, because as it is done on server side, if you are a game studio, you will have to pay for all this additional compute. And also the input latency is worse than the application or browser rendering. And we also have some scaling challenges. So I will explain later, but you need to process the point of view of each camera, so each player, and send it to them. So of course this is this has some scaling issues. Why is render streaming a very good use case for DeepSquare? So at DeepSquare, we have bare metal infrastructure, and we noticed that running render streaming applications on virtualized environments, like for example on AWS, have very bad performance. You have lag spikes, and it's unplayable. This is because the GPUs are virtualized as well as the CPUs. Also, as we are working with a skilled Unity developer, we are able to have multiple instances, meaning multiple players on just one GPU. We are rendering the point of views of the different players on just one GPU. So what are the render streaming services that we provide? Right now, only the Unity render streaming service. We will, of course, implement the pixel streaming 1.2 because we noticed that the community building on this technology might be more mature right now. So I will do now the demo of this. So many of you have not seen that. What you can see right now is the customer portal that is still under development, where we will be able to launch this job. So here we can choose among apps, and here we will choose this Unity render streaming application. As you notice on the header side, I have some credits. This corresponds to stable coins. So as you can see, I'm a millionaire here. I have $10 million. Of course, it is testnet, so I can provide myself any credits I want. And on the right side, we have the native token of the blockchain, so this Square token. In order for the Unity render streaming to work, we need to have a web server to send the stream to. And this will be hosted somewhere else, not on our infrastructure, because we have this HPC approach where it is complicated to have data going directly to the compute nodes. This is why the data will go out from the compute nodes directly to the web server that is hosted somewhere else. And this is where you can join, basically. So how it works, that you need to provide a zip file that is containing the games, basically, and also the binary path. So where is the binary in this zip file? Then I'm choosing the number of GPU I want and number of CPU I want. I will choose 1.4, and for the memory, I will choose 16 gigabyte of RAM. And I will put some credits associated to the job. The more credits, the longer it will last. So here I will put 500 credits. And let's start the job. So I've clicked on launch job, and here metamask will pop up and ask me to basically make the transfer of money. So the first time to increase my allowance, and the second time to actually pay. All right, so now the job has been requested, and now we can see on our blockchain explorer, that 13 seconds ago, some calls have been made, and I will explain what is happening. So here, we've submitted the job to the meta scheduler that is looking for the best cluster for our workload right now. And what happened after refreshing the page, the meta scheduler has chosen the Basel cluster to host the game, and the Basel cluster has claimed the job. So this means now if we connect to the web browser, we should be able to be in the game. And that's it, we are. I will just put myself in admin mode. Yes. All right. So here I can give you an invite. You can join. So normally this game is there to support 4 players with these current settings. So of course it might break if you all join. I will put the link in the. Maybe it's not a good idea. Can I share the address on only on the people for the people that are here, or am I forced to send it to the whole Telegram group? I will. Okay, let's try. I will put it in the Telegram group and hopefully not too many people join. So if you have a computer with a keyboard, because on mobile we will not be able to move, but if you have a computer and a keyboard, you can click on the link that I've put on the Telegram and you should be able to join. Please, not so many join, else it will break because it is made for 4-6 people. So here we can see people. You can move with WASD and move your point of view with the mouse. So here we can see the player has joined. And voila. Then I will go back to the presentation after a few seconds just to explain. So while people are joining, I will go back to the presentation. So as you can see, to start a job, you just need credits. You need a zip file and we are ready to go. What about this world, the DeepSquare Playground? So right now what you can see is not looking super great because it is a white block mode, meaning that we still need to do all the textures and the 3D assets. So yeah, not good looking, but we are working on it. And as you have maybe seen on the teaser, we are making 9 worlds where people will be able to interact with each other, for example. So what is the purpose of this project? As I said, render streaming is a very good application and use case for our infrastructure because it is using GPUs and it fits our HPC stacks a lot. It is a sandbox project, so we have not really a goal in mind for this project. It's a very good tool for DeepSquare to present its capabilities and also visual things to explain the project. So as you can see here, we have people left, but we can welcome many players, meaning on one GPU on our Basel cluster right now, the different points of view are rendered for each one. So on one GPU, we are able to have, for example, up to 8 players. As I said, we will have multiple worlds connected with portals. So these 9 players, for example, on 9 different worlds, will be able to navigate between the different worlds live on a single GPU. We intend to make this world open in the future so that it will be always available. And that people can join. Of course, there will be a queue system because, as you heard, we cannot scale more than, let's say, 10-ish players at their current resolutions, else it will deteriorate the performance. We are looking for solutions to make it scale. And the rendering, we are able to use multiple GPUs, but the encoding, we are not right now. So we will need to dig into these C++ libraries to improve things, and maybe we'll be able to leverage many GPUs, meaning that we will be able to welcome hundreds of players, for example. And this will start getting interesting for metaverse projects. It will be interesting to know what is the situation with the pixel streaming from Unreal Engine. Maybe they already support the multiple GPUs, and we'll see in the future. This is an example of what you can see in the zip file. So Unity game files, basically. What other services we are able to do just thanks to that? So being compatible with Unity now, we can have more than just Unity render streaming applications. We can theoretically host Unity servers. We will need to change the kernel of our OS images so that it will favor low latency performance because when you are hosting games, you want your players to have the best experience possible. But right now, we will be able to, for Unity developers, they will be able to use some editor tools to be processed by our infrastructure instead of their computers. For example, the baking of lighting for maps and the compiling of game builds. About rendering, so we're not talking about render streaming anymore, it's about rendering alone. And here we have, as you've probably seen here, Blender. And on Blender, we are able to render Blender jobs, basically, provided that the users manages his or her data with a S3 storage type. So as long as you have your input in an S3, we will be able to send the rendered files on the same S3 where you will get your data. So this works, and we would really like to have some Blender users to give some feedbacks, because we are not Blender experts. We've made this Blender working, but there are probably things that people might want to have on this interface. So we gladly accept feedbacks on this. And if you are a Blender expert, please contact us. We will be very interested. So how Blender will be used? It can be used, of course, in the portal here, but we are also working on the library for developers to be able to request Blender jobs without interacting with this front end. All right, now if you have any questions, I'm open to them.
Charlie, another question from the community was, will they be able to render HDRP 3D?
Yes, so I actually have a slide for this. So right now we are using URP just because it is less heavy to render. But tech-wise, there is nothing saying that HDRP is not possible, so it should work. And you will be able to have better visuals. But on the downside, I don't think you will be able to have that many players per GPU. So it's a trade-off. But if you wanted to make, for example, a single player per instance game, that would be very interesting. And you will not have the audio problem because you have only one player. So yes.
Charlie, I have one more question regarding the end user point. I see the viability that you can have access to more than access to the games without having real potential machines or computes at home. But I would like to know what would be the benefits to be running the pixel streaming or the render streaming from the project side.
Well, let's say, for example, you're a retail or a shop and you want to give this immersive 3D experience that you could call metaverse-like experience. And you maybe you want to have the same shop, but in 3D, and you want your customers to be able to purchase from there directly. And why not in crypto, you know? And if your customers need to have gaming computers to use this and buy things from your 3D worlds, it will not work. They will say, yeah, I cannot just, I will just go to the shop. So if you are willing, I mean, I think the best case is if you are making money out of people using this 3D experience, like retails and shops, I think it is worth spending this money into rendering compute on behalf of the users, because you know that they will bring you some revenue, for example. And so you remove the barrier of having good computers to access that.
Okay, I see the point. Thank you very much, Charlie.
You're welcome. Also, it is very, for example, if you are making 3D assets, for example, you are an artist and you make cars, like supercars in 3D that people can use in games and movies. The problem right now is that if you want to give a preview of these assets, for example, with WebGL, people will be able to steal it through scrapping, basically. They will be able to steal your data and steal your art. And if you stream it instead, there is nothing they can do. So it makes your art protected. This is another use case you can have.
Thank you, Charly.
So we also owe you a quick answer to a question we had during the week about the token SONM on that project. And Maya has looked into it a little bit and would like to just give a quick answer here, but I'm sure we will also publish a full answer tomorrow, yeah?
If needed, yeah.
Okay.
So just the comment regarding the question we had. So the biggest difference between us and them is basically they're more similar to what Akash is doing than what we are doing. They're marketplace, and this is where they stop. And also they're accepting individual contributions to the network. That if you have like a really good gaming PC with really good GPU, you can join their network, and someone else can use your PC while you're not using it. But this is not what we at DeepSquare are doing. It's a professional decentralized cloud, meaning that the resources we offer are supercomputing resources. And I'm super happy to go in detail. If anyone has any additional questions, we can discuss this in more detail.
Yeah, to give an example, if you want to train an AI model on 100 GPUs, good luck using their services. Whereas with ours, it's possible.
Exactly. Yeah.
All right?
Great, thank you. I think it's the underlying carrier grade, I would say, enterprise grade, professional grade infrastructure need for that is clear, I think, for everybody. And the difference between what we want to achieve and what some other Web3 competitors have done is clear as well.
All right, thank you everybody for joining the session. And yep, have a good evening and see you next time.
Thanks, Charly. Thanks, everyone.
Bye, Charly. Thank you for the presentation.
Thanks, bye, Charly.